Assalamualaikum 10th class. Hope so you all are fine. 10th class, today beta we are going to do numericals of unit 18, and the numericals that are included in smart syllabus are 18.1, 18.2, 18.3, 18.5 and 18.9. So first we will do 18.1. The half-life of nitrogen 7.3 seconds. A sample of this nuclide of nitrogen is observed for 29.2 seconds. Calculate the fraction of the original radioactive isotope remaining after this time. When we solve it, they have given us a half-life of nitrogen, that is 7.3, and time t they have given us 29.2 seconds. Remaining fraction of original radioactive isotope we have to find, and this we will write during 29.2 seconds 4 half-lives are elapsed. If nitrogen N naught is the original fraction of the nucleotide of nitrogen, then after 4 half-lives, that is 4t1/2, remaining fraction is equal to original into 1/2t, and remaining fraction we will denote with n, and for original there is n naught, and 1 by time is the 4, because we talk here about after 4 lives, and we write it in this way. So n over n naught is equal to 1/16. Here, after this we have next numerical. Cobalt 60 is a radioactive element with a half-life of 5.25 years. What fraction of the original sample will be left after 26 years? So half-life of cobalt 14 they have given, we will write it in this way, that t1/2 half-life, and that this is 5730 years. Then time, that is the 26 years, and remaining fraction we have to find. During 26 years 5 half-lives are collapsed, so remaining fraction is equal to original into 1/2t. So n naught is equal to 1/2 into 5, and then by moving n naught this side, n over n naught, we get 1/32. Clear? After this, 18.3, carbon 14 has a half-life of 5.7. How long will it take for the quantity of carbon 14 in a sample to drop to 1/8 of the initial quantity? So time we have to find, and as the quantity of carbon 14 drops to 1/8 of the original quantity after 3 half-lives, therefore time is equal to number of half-lives into half-life. 3 into t 1/2, that is the half-life, and 3 is the number of half-lives, and when we divide 3 into 5730, time we will get, that is the 1.72 into 10 raised to power 4 years. Clear? After this, 18.5, half-life of radioactive elements is 10 minutes if the initial count rate is 368 counts per minute. Find the time by which count rate reaches 23 counts per minute. Half-life t1/2 is equal to 10 minutes. Initial count rate is 368 counts per minute, and final count rate is 23 counts per minute. Time taken we have to find. For the count rate to decrease from 368 counts per minute to 23 counts per minute, it takes 4 half-lives. Therefore time taken is equal to 4 into t 1/2. So 4 into 10 minutes, and time will be 40 minutes. After that we are going to do 18.9. 18.6, 7 and 8 we leave, because these are the that we have to do on graph paper, so we will do it later. Now we are going to the last one, that is 18.9, ashes from a Campfire deep in a cave show carbon-14 activity of only 1/8 the activity of fresh wood. How long ago was the campfire made? So activity of carbon-14 from ashes is 1/8 of fresh wood, and the half-life of carbon-14 T1/2 is 5730 year, and the time we have to find. Since activity of carbon-14 from ashes is 1/8 of fresh wood, hence 3 half-lives have been elapsed. Therefore, time is equal to number of half-lives into half-life. 3 into 5730 years, and time will be 1719 years. Sorry, 17190 years. So these are your numericals. Do practice of all these numericals.